Hello all. Thank you for letting me speak at this event today. I'm Sebastian Murphy. I'm the Technical Director for Data Centers across EMEA, which is Europe, Middle East, and Africa. So what I'm going to talk about today is integrating digital technologies into project planning, design, construction, and management. I'm going to quickly give you a glance of the company I work for, the introduction and importance of what we do and the issues we're seeing ahead of us and how we're trying to mitigate those issues. Then I'll take you through the design area, through to planning, construction, benefits, and then into the challenges we're facing. So Blue 3, the company I've been working for just over a decade. We are a UK company with offices in the UK, Denmark, Germany, Ireland, and where I'm based with my colleague Joey, who's standing at the back. We have our technical department that's based in the Netherlands. We, as the international technical team, we look at primarily data centers. We also look at other big civil works like pharma, but yeah, data centers take up about 90% of our time. So the technical department in Blue 3, I've come from an operational background, so as an engineer on site, all the way through to project management. And about 4 years ago, we set up the technical department. What we saw was, as we were moving on from just doing one project at a time, we ended up doing multiple projects, and we believed that some of the knowledge was being left on certain projects. So we wanted to bring that knowledge back into to the company so we can go across all those projects. And of course, we're a cross-department collaboration, so we collaborate with the planning, with commercial, with operations. We're involved with the full life cycle of the DC projects. So where we started off, we were just in operations. We were learning on the job as we started and growing through. Slowly but surely, that digital trend came in. So from when we looked at 2D drawings, trying to coordinate and find clashes in the 2D realm, we then saw the industry change and bring in that 3D BIM modeling, where we could then visualize those clashes, those difficult project conditions into the digital realm, and then we would take it through. So not just from operational, but also into the pre-construction. So we started at the end, slowly brought ourselves across to do at the beginning of the mobilization of the project. So everything we've learned, we could start at the beginning. Then we realized that was too late in the process, and we slowly stepped it back into the tender period where we could have a discussion with the client, work through where we see within the digital realm that we could actually benefit and learn those lessons. And even at that stage, we saw that was too late, so we went back even further into the PCSAs, which is a pre-construction service agreement, where we would work with the designers, with the client, all the way back at REBA 2, REBA 3, 30% and 60% design, so we can actually make those changes as early as possible. So the introduction and importance, why digital transformation? So within the data center construction, it's very complex, all the way through from the utilities coming in, through the build of the steel, cladding, the difference between where the design sits with the client, where the contractor has a certain design proportion, then that coordination and that collaboration between multiple countries. So we have we'll be based in the Netherlands, talking to designers in the UK, talking to the client who's in America, and then trying to find that platform where we could all communicate and actually work through these problems. Before that sort of BIM world came alive, we were seeing these high-risk activities were causing complications on site, delays, and of course, budget overruns. So then what we move on to is how can these digital technologies streamline the processes? So the importance of increasing that precision. So taking a certain level of development of a design, which you are handed over, adding that detail, understanding how that detail affects the current designs or any principal issues, working through those issues together, and in fact, you end up de-risking the activities and improve the project outcomes. So in data centers, I'm sure a lot of us know about data centers now. I've been in the industry for just over a decade, slowly seeing it growing. Last year, we hit a point where it seemed like the industry had calmed a little bit, and then we've seen an exponential growth this year. Obviously, with the discussions of AI, the increased power demands, the change in facilities, we've now seen a huge growth. And from 25 to 2030, just in Europe, we can see the spend is only increasing. This has effects because you're going to be building multiple projects. There's only a finite number of people who can build these projects. There's only a finite number of people who can actually give their knowledge to the project. So we see that importance come back to that digital realm, where we can actually start servicing multiple projects with that same knowledge, and in a realm that is digital, it's prior to works being started on site, so we can work through those issues, building up those partnerships, which the contractors, clients, subcontractors, and the people, more importantly, the people who are installing and are on site, that they're doing that in a safe manner. So a little bit about the design. The standard procedures and standard contracts we have is where we have the client design is brought up to a certain level, then we tender on that, and then if you win the tender, you then have to take that design and add in your CDP elements, which is your contractor design portion. So for instance, if you look at a primary steel frame, those principles have been given over by the designers, and then you have to further design the secondary steel. So how we detail, how we tie in, and how we keep to those design principles. If you look at the underground services, which is what my background and my colleague Joey's background is, where we started 10 years ago, it's a huge amount of services, very complex, and what we tended to see is the design, as you can see the one here just over to your bottom right, that was the client design that's handed over to us. So they would see it as declashed, ready to go, ready to build, and then it would be handed over to us as the contractor to then bring in technical submittals, what size of the chamber, the details of the actual duct systems, the pipes, and then we have to integrate that into the design. And what you would see is clashes, issues with the actual design principle, so we have to work through that in a digital realm to bring in a design that we could actually install. And what you actually pick up there as well is how are the guys on site? How are we operationally going to build this? How can we safely install these services? How do we excavate down 4 or 5 meters to allow for this? So the big part for us when we start on projects is integrating that client design with our contractor's design portion. We see an improved accuracy in clash detection. The earlier you can do this, the better for the project. This then has an impact on cost. This then has an impact on the program. And this enhances that coordination and collaboration with the client, with your contractors, and also with the guys who are actually installing, guys and girls who are installing the services on site. The streamline approval and faster decision making. Again, this is something that's very difficult to work towards. You're working with, again, multiple people, multiple cultures, multiple communication styles, but when you're all into that BIM atmosphere and environment, you can actually see that those approvals and faster decision making comes in, which then, most importantly for these projects, is that cost and time efficiency. So an example up on the screen there, we have 2D drawings. Originally, we would just do it in 2D in detail. You can just slightly see the numbers there, but now we can work in the 3D realm, which actually shows how do you interact pipes with ducts, how do we build it safely. You're showing the client, this is what we need to do. You can showcase the complexity of it, and then move on from there. So after we've done the 3D modeling, as you're working through the coordination and the further detail, we then bring it back into sort of that project planning. So you combine in the 3D BIM with the construction schedule. So obviously as the design's being detailed, certain activities might become longer, they might become shorter, you might find glaring issues, and then you can actually go into the program and the planning of that work. So that's bringing that 3D model in and showing that time base. So you bring it from 3D to 4D. So each construction phase is integrated within that timeline, showing how, when components will be built, which is brilliant for giving that visualization to the client, to your multitude of subcontractors as well. So, of course, the goal for this is always to streamline construction, reduce delays, shorten time frames, and optimize that resource usage and anticipate challenges. So on the screen here is how we look to, you obviously have to always start with the welfare. How can you get the guys to work? We do this through VR. We have a standard template of this is how welfare should be built for 80 men working on site, 140 working on site, 200, 300, 400, etc. So as you come up with labor, you have the right facilities in place. This then gives the client the understanding of how we're going to actually set up a safe environment and a clean environment for the workers. So this helps with the resource and cost efficiency, and that enhances the flexibility. So I'll show you the 4D slide here. So I couldn't show you the full 4D animation because obviously we're under NDAs, but now we see that 3D model into a 4D planning, and this is how we use it for all the data centers we're on now. So you can showcase the heat maps of labor. So where do you see that labor intensifying? You have a lot of labor as you're coming out the ground, you're then building the steel, you're then doing the roof, you're then doing the cladding. So it shows that there's a lot of coordination, a lot of contractors, and this enables us to plan, safe levels for the guys and girls to be working at. And as you move through, you can see more contractors are coming in, more people are on site, there's a higher risk of incident and accident. You have exclusion zones from cranes, so you can really put all those points onto the 4D planning and actually see where there's any challenges ahead. And then from the 4D, from your planning program, you then can input live data, and you can see if you're actually hitting the targets you've set out during tender, during mobilization, and then it pinpoints where the areas that we're not hitting those. So it gives you that real live data, but you can then see it in the animation. You can then zoom into where we see the issues, and then we move on from there, coordinate, collaborate, fix the issue inside the office with the people in a safe environment, and then implement that on site. Furthermore to 4D, what's the most important thing from a contractor? Blue 3 are not only a GC, we're also a specialist package contractor, and we also work as a subcontractor. So when we're actually building, and when you go through the 3D, people tend to forget to put in how are we actually going to install, how the temporary work's going to be, how are we going to achieve the depth we're trying to get to, how are we going to achieve the most complex areas of build. So we've then taken it further, and with the clients as well, is to have those health and safety benefits of 4D planning. So again, when there's a lot of trades, when there's a lot of conflict in areas, when there's a lot of activities, we can then plan out the safe access, the safe egress, and then the safe works. And fundamentally, the most important thing for construction is the safety of the people working. So VR in practice during the construction period. When we're during the early days, we present the welfares, the logistics, how traffic's going to move, how deliveries will come in. This gives you the full project understanding, so you know as you're building, there's also many other activities happening. How do they safely get in? How do they safely get out? We do this in VR, so before we can build, before we can show them on site, we can show them in the virtual reality of how we're going to build, how the site will look, and then we can build to that. Again, in construction, as we've gone on, quality control, quality assurance are key. So as we are installing, we need to verify, are we installing it correctly to that design, to that new coordinated, collaborated design? How do we pick up if it's been installed incorrectly? How do we set out those areas that are set out to those high tolerances? So very small tolerance in installing steels, even underground services, pop-ups, because you have electrical equipment coming in. Once it's built, you cannot move it. So we set up with robotic total stations. We then go around and do 3D laser scanning, which then gives us a clear picture of where we're not meeting those tolerances. Again, all through that quality control, quality assurance, running through that life cycle of the project. And then during construction now, so instead of having to wait when something's built, then you do a 3D scan. If something's picked up, then you have to rework, you have to take things apart, and then you have to rebuild it. So here you can actually see where you've got some containment, where it hasn't been allowed for an opening. So during the actual construction process, just before they're going in for works planning, we can actually have a look to see, has it been built correctly for the follow-on trade, and is there any issues? So then we can mitigate that time delay. Another example here is for underground services, where we use site vision for this, Trimble site vision to show exactly what services are following. So as we've excavated, we can show, okay, this is the trench, this is the complexity of the job. Once we excavate and build, we go on. So all these are real tools that will help day-to-day in the actual project delivery. So the benefits, I think it's clear digital integration benefits everyone, benefits for the full life cycle of the project, from planning to actually operating, and then the safety of people. We've seen enhanced collaboration, cost and time savings, and sustainability and efficiency, which is the new drive. As we standardize the designs and go further, we're then looking to standardize products. We're using robotics at the moment, 3D printing that can bring in carbon savings in concrete. But there's the key challenges. As we're moving forward and across different zones, the key areas we're seeing is that training and skill gaps. There is a certain amount of people who have that knowledge. There's a certain people who can actually do those works, but we need to upskill the whole trade. We have to upskill the whole supply chain. We all need to be doing the same things. Then we have data security and privacy, the initial cost investment. As we want to improve the actual projects, we need to do an early cost, so we need to put that money in up front, early doors. And then, of course, as discussed before, it's that change management. How do we manage that change, and how do we bring that into the industry? But yeah, hopefully that's given you a little bit of an insight into how we use the digital realm within data centers. So thank you.